Is this thing on? Good morning. All right, before we get started, I'd like you to take a quick road trip with me. It's almost May, temperatures are getting a little bit warmer, and so our thoughts naturally shift to vacations. So one of the first things that we do is we take out our roadmap. Now, I don't mean on the computer or on your phone, I mean a roadmap. That piece of paper that you have to unfold 18 times to see it in its fullness. And you take out your red pen, you circle where you're starting, and you circle where you want to go. And then you mark all the landmarks and milestones in between, everything that you want to see on this trip. Now, the thing about having a roadmap is that someone has been there before. Someone has been where you want to go, and they collectively took the time to write it down. Well, what do you do when there is no roadmap, where there isn't a clear path to where you want to go? Your destination or your path is so unique that you have to do a little bit of guesswork. What if there is no roadmap? Well, you create one, which brings me to our roundtable. The domestic agencies have been charged with bringing the best, procuring buildings, systems, components, and bringing it all to Iter in an integrated fashion. My colleagues on the stage are representing the 7 domestic agencies of Iter. And with their years of experience and their commitment to Iter, they are each trailblazers in their own right. For this roundtable, I'll begin with introductions of our guests, and then each of them will give a short presentation talking about their successes and opportunities. And then I'll come back and close with a time for questions and answers. So with that, I'll begin with introductions. First, we'll have Wang, who's the Deputy Director of Iter China. Next, we'll have Marc Lachaise, who's the Director of Fusion for Energy. Next, we'll have Narinder Singh, Senior Project Manager for Iter India. Next, we'll have Taro Matsumoto, Head of Iter Japan. Followed by Kijung, Jung, Director General of Iter Korea. Anatoly Krasilnikov, Director of Iter Russia. And last but not least, Kathryne McCarthy, Director of US Iter. So I will now turn the podium over to Wang.
Good morning, everyone. I'm Wang from Iter China. I'm so happy to here to share some information about Chinese activities for Iter project and our fusion development. And firstly, some general information. As we know, the Chinese government strongly support the Iter project and the fusion development. And some policies have been released to support the development and the utilization of clean energy, including fusion energy. Iter project and some domestic program have been implemented to do R&D work, complete some commitment for Iter project, and solve some technical issues. This is our center's organization. Our center's named China International Nuclear Fusion Energy Program Execution Center, which has been designated as China DA. This is our structures, very simple. 3 divisions have been working for the Iter TPM International Corporation, and 1 division are working for the domestic programs. And our mission is promotion of the fusion development. We believe openness and cooperation is the best way to solve global energy issues, so we have actively engaged in the bilateral and multilateral international cooperation in this area, and the steady progress has been made. That some pictures show you. And since 2019, China Fusion Energy Conference, CFEC, was held every 2 years. So I would like to welcome all of you to join the next conference next year in China. Highlights. Totally speaking, 18 PAs have been signed between IO and the CNDAs, and the 7 PAs have been completed. About 30 main supplies and 100 sub-supplies have been involved in the PA tasks. With very good cooperation and communication with IO and other members, some big achievements have been achieved in the last year. For example, the first set of ICC code tests have been successfully completed. The result was perfect, and we plan to complete all of the delivery of the correction core this year. For the power supply, with excellent teams and rich experience, design, manufacturing, and delivering, and the installation has been successfully. The Iter Stage 1 MCPS and RPC. And there's some commissioning work has been completed as well, very well. And the first batch of the shelled blanket was delivered to the Iter site, not only for the component systems, but also the standard. We have also emphasized on that. Until now, 1 ISO standard have been released, and 4 standards have been under development. About 200 standards have been released by our center, including 16 standards which has integrated into our CCMRX RPP phase. The highlights is not just the highlights itself. What's more, it provides a good evidence to prove that Iter is a good opportunity for all of us to open mind, open eyes. It's also a good opportunity and platform for industries, not only for the Chinese industries, but also for the industry in the world to improve the capacity and enhance international cooperation and perfect management philosophies. Let me give some good practices. Firstly, Iter provides a good opportunity to enhance international cooperation. Sino-French-Italian cooperation is a very good example. The big milestones sector model 7 moved to the pit, which happened in this month, was successfully done by the cooperative group. Secondly, Iter is a good platform to enhance communication and information exchange so as to accelerate some specific technology development. For example, the annual meeting of the Iter conductors was held to share their experiments and the lessons learned, which is very, very useful to effectively promote the superconductor technology in the world. Thirdly, Iter boasts the recognition for the industries in the related area through taking some Iter tasks. Some companies' names have been listed in this slide. In fact, there are a lot of examples to support my points, but consider the limited time, so I only list several. And some information about our future work, especially for the PA work, also listed in this presentation, including diagnostic, first war, and the GDC, including the scope and the stage, and the challenge and opportunities. I don't go through the details. If you are interested, we can discuss after meeting, or you can contact us. Now, I only want to say, as Chinese saying goes, dreams and wishes may be far, but it can be fulfilled through a dedicated pursuit and joint effort. So, we welcome cooperation with everyone here to jointly realize our common dream, fusion. Thank you.
So a few words from the European perspective as Director of Fusion for Energy. First of all, it's my first Iter Business Forum. Very happy to be here. I'm still quite new in the community of fusion, and I take this opportunity to thank other people from this quite a strong community who welcomed me in the last 2 years. So I will start by a few informations about Fusion for Energy, our vision, our mission. I think it's good we share that with you because things have changed maybe since the last IBF. It's time, I think, to celebrate. I think Pietro showed a few slides, but I would like to go a bit more detail on some achievements we can be proud of. When I say we, it's of course us on stage, but also, as Pietro was saying, in the factories and in all your companies. A few words about the fusion supply chain and then business opportunities, because I think, of course, this forum is a fantastic opportunity to celebrate successes, but also to network and to think about the future business you can hope to get with us. So mission and vision. So Fusion for Energy, as you know, probably is the European Union joint undertaking for Iter. And basically, our objective is to deliver the European contribution in terms of in-kind to the Iter project. To do so, we are organized around quite a big team, I think, of more than 450 staff members, based in Cadarache, based in Barcelona. We have a few colleagues also working in Garking, and a few others not directly linked to Iter, working in Japan, in Naka, and in Wakasho. Fusion for Energy is basically reporting to all the EU member states and to the European Commission. So we represent the 27 member states. We are, by definition, Iter is a multicultural organization. We are a smaller scale, but I think it's already a fantastic scale to have more than 20 European nationalities working in Fusion for Energy to deliver Iter. Our vision is, I would say it's at the same time very simple, but I think it's embarking a lot. The vision approved by the governing board a few months arrived in December 2023, which is the result also of a discussion of participative leadership inside Fusion for Energy. It's based on 3 pillars. The first one is really to make Fusion for Energy a delivery organization. The main objective is to have all the components we owe to Iter, we owe to the other agencies, to be on time, on quality, on budget, on site. And this means a lot for us. This means a change in the organization in the recent months. This means a focus on delivery, a presence in the factory. I hope we're not too present, but I think it's really important we understand what's going on in your workshops. So that's the first pillar. The second one, and I think fusion is really important for that, is the human factor. The story of fusion is a long one. Started a long time ago and will finish probably when most of us, or maybe there are some young colleagues here, will retire. And I think working on our people in all the organization is key, to bring the new talents, to make sure they learn from the olders, to also give time to the olders to retire, and then to have a long-term perspective. And the last one is the supply chain. We are nothing as an agency without the supply chain. We are nothing if we don't engage with all the suppliers, and you're doing the job, and the people in your companies are doing the job. So delivery with people and working closely with the supply chain. F4E, we can define us, I think, as a hub for design, engineering, and project management. I won't go into the details, but you see here what we bring to the project, but also to Europe in general. A set of unique competencies, like in all the DAs and in Iter. I think we learn a lot about how to deliver first kind or even single of a kind project, and we do it as a team. We have also an extensive knowledge of the European supply chain we're dealing with for many years now, and this is really a great asset, I think. So, a few pictures and a few achievements. The first one, so if we go back to the previous IBF, it's a long time ago. It seems like, I think the COVID changed many things also in our lives, so it was before the COVID. But if we take stock of the achievement, I think the biggest one, or one of the biggest one, the most iconic one, is the delivery of the tokamak complex. This was achieved last year, starting a long time ago. My first visit to Iter before I joined Fusion for Energy was to see a big hole, and it was the beginning of the story. So this has been delivered by key supply chain partners like Vinci, Ferrovial, Haselbeck, and it employed nearly 1,000 people. It was challenging because of the evolution of the design, as you may know, but it was properly delivered to the organization. The other one, and Pietro mentioned it, is about the TF core. This is a long story and started in the 90s with a lot of research and development, and a story also which is taking us to different places in Europe, ICAS in Torino, AHD in La Spezia. We had also Elite and Iberdrola, CNIM working, CIMIC, and it was in case in some Japanese also equipment. Just to mention, you might say it's not Iter, but it is related to Iter. You know, today the biggest tokamak in operation is in Japan. It's a joint collaboration between the EU and Japan, and QST, and I think what we're learning also there is benefiting Iter, and it's one of the achievements I wanted to share also with you, because some of you are also part of this story. We mentioned the TF, now we go to the PF coil, also an impressive delivery with a lot of collaboration between different companies, 10 companies, and if I start to do the list, I think I will be out of time. It's made of niobium titanium, which is what is required for this high magnetic fields, lower than the other ones, as you know probably better than I do. On the vacuum vessel, this has been a long story, and I'm sure in 2019 it was part of the expectation. The first European vacuum vessel arrived on site in October. I had the chance to see the last days, because it takes 3 or 4 nights to go from Marseille port to Cadarache. And I take the opportunity also to thank people working for all of us here, which is the team working on transportation, with Daher, but also with the French authorities. We had some representative yesterday. I can tell you I witnessed the presence of 50 armed gendarmes, French police, around the convoy, and our equipment are properly protected when they go on site. So the vacuum vessel, the first is there, and you will see the second is on his way. We can mention also briefly the Mythica beam line, which is done in Italy, in Padova, with also a collaboration with Japan QST, and a few more buildings, auxiliary buildings, like the radio frequency building and the cryo plant building. Here we can note the work also with some partners for those two equipment, and in particular the job done by FOE and his partner about construction, piping, and control system. The second European vacuum vessel, so I try, I know I'm not doing that enough, but my team is going also to visit the factories. I think what we achieve here in Europe and in different parts is also a manufacturing story before coming to site. And it was quite impressive to see the vacuum vessel close to Pescara in Italy, in Water Tosto premises a few weeks ago. And we realize also as well, with the presence of local stakeholders, the impact we have on the economies we have across the globe, because we create jobs with fusion and with the components for Iter. So this is the vacuum vessel, must be on his way at the time we speak. And we can mention also the deliveries of the 8 Taurus and cryopump, with in particular Research Instrument and Alcimex as key partner. Few words on the organization. I know it might look a bit boring and don't go into the details if you want to know more, but I think it is to show that we're working as IO in a more matrix way to make sure we deliver better our components and to also make sure that we take on board the deep knowledge we need to have in terms of engineering and fusion technologies plus the supply chain. So a matrix organization which is more flexible and which has been also aligned with Iter organization to be more integrated. So in some of the activities, like in the buildings, we've been through a very big job to have more integration and to work as one team, which is basically taking out one of the interface, which was sometimes a bit creating some difficulties and inefficiencies. The fusion supply chain has been created with 7 billion that Europe has been investing in Iter through FOE. This is only the amount of going through FOE. Of course, there is a contribution to IO activities, but it's more than 1,000 contracts, 700 industries. Impossible to count the subcontractors because we're dealing with so complex equipment that the limit of T2 and T3 is really difficult to catch up. But I think you can see here the magnitude, and I would like to mention as well the research organization. Pietro was mentioning rightly before that we still have things to crack for fusion, and I think we keep engaging with research organization as well. This is another way to represent it. We work with 23 of the EU countries. We have the challenge to reach the 27, but it's also a message I want to send, is that all the procurement we're making is public. It's under EU procurement law. So basically, as European company, you have access publicly to what we tender. We will give more information later today and in the coming days. Everybody has a chance. And we are very strict to be fair, to make sure we compare the bid like for like. So really a very strong and robust, sometimes heavy procurement process. Here we also are building the resilience, not only of Europe, but I think across the globe, to have a knowledge on the different technologies and to work on the mapping of those technologies as well. The objective is to empower and to keep supporting companies. Of course, our focus is Europe by offering more visibility also to SMEs and facilitating partnership. You can have some more information on our webpage, and you can visit also to FOE in the booth and meet a few colleagues if you have any question, because I would like that each of you has the opportunity to meet us if you want to in the coming days. We are starting a process which has been quite successful till now on making sure that we identify the gaps and priorities in fusion technologies. We're running at the moment in Europe in fusion for energy some workshops on different technologies, and we are working also a way to support better EU private initiatives, which was not in the DNA of FOE, because when we were born, startups were not existing in fusion. But I think it's our duty to understand what they do and to try to support. They take the risk, of course, but I think it could be a nice success story for fusion as a whole. And I welcome the 2 days you had in Iter in this spirit as well. Maybe time to conclude. I think we've been working also on different subjects. The big science organization, it's something which is of interest, I think, for us, and I think for Iter in general. We are very similar in our requirements, in the complexity of things we ask to other organizations, like SAN, for instance, international organization, pushing the supply chain to the limit. So we keep working with those organizations as well to foster more ideas. We had an SME day because it's difficult from those big organizations to engage also with SMEs, which are the heart of the European economy. And we will organize another SME day and a supply chain day in Barcelona end of September and in October. Business opportunity, very briefly, you will have all the time to engage with the colleagues. This is just the flavor. I know there are specific presentations in the coming days, so please come to us. I don't have time to go through the different points, but cryo, fuel cycle, diagnostic, investor, there is still a lot to go. Time to conclude. I think I said everything. Our objective is really to keep the momentum of delivery. I think we are in line with the SPI, the project, close to 1 for the critical path. We improved from 0.6 to nearly 0.85, so this is getting better. We should not forget that nuclear safety and safety on site, because we've been running the buildings, is our priority, and the rest, I think, it's just a summary. Time for me to conclude, really to thank all the supply chain partners here who've been delivering with us, and hope to meet new ones in the coming days. Thank you very much.
Good morning, everybody. This is Narinder Singh, and I am representing our DA head, Ujjwal Barua here. And in this very brief presentation, I will talk about the overview of the DA activities and the major milestones we have in the past and the recent times, and also about the major procurement activities that we are looking for, and about the areas of mutual interest and opportunities. So to begin with, as we know that we have 9 packages for the Iter, and we have cryostat, involved shielding, cooling water systems, and cryogenic systems. In the visit to Iter site, you probably must have seen these systems being installed and erected at site, and these works are being done by various industrial partners, including the service providers. And for the rest of the packages, which include high power amplifiers for the IC system, megawatt gyrotrons for the AC systems, diagnostic neutral beams, power supplies, and the diagnostic packages, we are doing a lot of developmental activities at Iter India Lab. We have been doing a lot of integrated operations of these devices at our site. Just to provide a glimpse over the various activities that we have been doing for the Iter at site, to begin with, it's cryostat, and it's a gigantic outer vacuum shell of diameter 30 meters and height 30 meters. And this is probably one of the largest efforts and engineering in terms of the large size assemblies and fabrication works at Iter site. And this job is executed by Larsen & Toubro from India. And then we have the TCPH, the deliveries we have made very recently at Iter site, and the set is also completed. So these activities actually represent a lot of integration activities among the Indian industries and the industries at site, and a lot of integration effort among the Indian and IO teams together. So it's really a nice experience working at Iter site on this part. Moving to the involved shield and cooling water system, involved shield blocks are already delivered, and this job was executed by Ausala Technology in India and L&T again. And cooling water is, again, a good experience in terms of the very large plant integrations at site. And this is configured with megawatt chillers and the devices. This job is, again, executed by L&T with a lot of Indian suppliers providing the components. And it is very good to see that we have the cooling towers put into operations in 2024. So this is again a good example of the integration we could do with a lot of partners at site. So moving to the cryogenic systems, this is again a good activity at the Iter site. I would say that it's a long activity, and we have done the cryo lines, which is vacuum jacketed cryo lines with a length of around 5 kilometers integrated together. And this is again a job where we did a lot of integrations with the Indian suppliers, as well as the supports from the industrial partners across. And by this time, we have completed almost like 90% of the job at Iter site, which is a very satisfying number. On the cryo distribution system part, we have already received the auxiliary cold boxes, and they are positioned at the at the site, and the FAT of this TCVV is also completed. Again, in this package, we have integration among the various Indian suppliers, Air Liquide, Linde, and HI Corporation Japan. So it is again a very good example of integration work among the different partners and industries. Moving to the RF systems, it is very satisfying that we have at least 2 operational beds at Iter India lab, and we have been operating the devices similar to the Iter specification at our lab. So we are operating 1.5 megawatt amplifier chains for the IC systems regularly to the Iter specifications. And also the 1 megawatt Gyratron operations we are doing with our power supply systems there. So we have been operating these systems. And I believe this is a good value addition to the system before we dispatch this to Iter, and we can attend to the needs of the load integration aspects in advance. Moving to the diagnostic neutral beam systems, this is composed by various beamline components and beam source. And in the recent times, we have received these very important components from PV Tepla, Germany, and we have done the integrated testing of these devices at the vessel in Indian side. So this is also providing us advanced acquaintance to the systems that need to be integrated at site. So it is providing us a good exposure on that part. And we are also expecting the beam source vessel to be ready by end of this year and probably available by the first quarter coming year. So we're doing a lot of activities on this part at our lab. Moving to the power supplies, so by this time we have developed fairly good or matured solutions for the power supplies. We have been operating these power supplies at Indian lab since 2014 with the high power amplifiers, with the gyratrons. And in fact, we have completed the final design review stage of these power supplies, and we are into procurement stage now. We have one more example of the power supply being installed and integrated at Spider facility, which is in operation since 2018. So on the diagnostic part, we have various packages, and some of the packages like XCRS survey and ECR, they are moved forward for the FDR. And there are activities we are doing at lab for the ECE diagnostics, transmission systems and calibrations, and we are doing some development things on the optical bundles as well. So moving to the forthcoming procurements, we see a lot of activities in terms of procurements for the IC systems. We have already started the call for tender for these activities. For the EC system, we are expecting the FDR this year, and then we will begin the procurement activities for the gyratrons as well. Regarding the cooling water system, we have new procurements, which we have already initiated with the industries. Power supplies, we are already completed the final design review, and we are into the procurement of these systems. Regarding the diagnostics, we will be completing the final design review this year, and after that, we will have the procurement activities initiated. On the DNB part, we have most of the components already being procured or are being procured, and then we will get into the large diameter vacuum seal walls for this. And since we see that we have a lot of packages which are of functional nature, and these packages will also have the involved scope of site installation integration at Iter site. So we look forward for the industrial partners who can support us for the installation and commissioning services, and we are looking forward to that. So this is a glimpse of some of the partners who we are working with from India and abroad, and I'm very thankful to them. And we are certainly looking for more partnership between various industrial partners. We invite different models of working together, ideas of working together. We would like to utilize the resources from the site, from our industrial partners, and we would see that we can bring up some model which is more convenient to work with, more flexible to work with. Thank you very much.
Good morning, everyone. My name is Taro Matsumoto. Thank you very much for giving me the opportunity to introduce our activity at the IBF. So this is the content. At first, I would like to explain the overview of our procurement and major activities since last year. And we would like to summarize our activity. Thank you very much. And at first, it is a schematic view of our in-kind procurement by JDA. We are in charge of TF coils, CS conductors, 7 diagnostics, 8 gyrotrons, neutral beam injector, diverter, OVT, remote handling system, including initial assembly tool, and some part of tritium plant. And I would like to say that in order to meet our responsibility to deliver the 9 TF coil structure to EUDA, we had a good collaboration with EUDA and KODA. And in order to secure our delivery of CS conductor to USDA, we had a good collaboration with USDA. And as for the diagnostics, we have a good collaboration with KODA on lower port 2. So what I would like to say on this page is in order to meet our schedule and quality, it was essential to have a good collaboration with other domestic agencies. And the next slide is our achievement since last year. As for TF coils, we have successfully completed our mission. All of 9 Japanese TF coils were successfully manufactured and delivered by the end of 2023, and the ceremony to mark TF coil completion was held last year at the I.O. And as for gyrotron, 8 Japanese gyrotrons were successfully manufactured and delivered to the Iter site by the end of last year, and now the assembly and installation activity is ongoing. And next slide is we are in charge of full tungsten diverter outer vertical target, totally 58. So now Iter diverter OVT prototype was manufactured and qualified. So now we are implementing the series production. And this is the activity of blanket remote handling systems. So first hole handling tests are ongoing using full-scale prototype of vehicle manipulator. JDA confirmed the feasibility of robot vision technology, which uses a pattern recognition of non-target image to obtain the relative distance between the manipulator and the first wall. And we have 2 topics here for diagnostic system. It's a mock-up manufacturing of retroreflectors on the first wall. And the factory qualification test to demonstrate the manufacturing process of the retroreflector was successfully completed, and manufacturing has started. The mock-up manufacturing confirmed that the mirror angle satisfies the requirements. And another topic on plasma diagnostics, some JDA and KODA cooperated in the manufacturing of the diagnostic rack mock-up. The rack locking mechanism was established by our JDA. This mechanism was adopted as a common design for all lower port for Iter. And I would like to summarize our activity. This is the overall schedule of our procurement. 18 years has passed since the first procurement agreement was signed in 2007. So now we are in the half of our activities. And from it's the overall procurement progress. As you see, roughly speaking, half of our procurement has completed. And this is the final slide about the JDA contracted industries in this IBF. For example, Allied Material Corporation is good for tungsten monoblock for diverters. Yamato Gokin is capable of copper chromium alloy for piping and diverters. Tokyo Electrons is good at auxiliary power supply for gyrotron Sugino machine, and Sojitz Machinery Corporation in close collaboration with Creo in France, good at blanket initial assembly tools, and early server manufacturing is capable of insulating material for TF coils, and Kyocera has contributed to the HV bushing for neutral beam injectors. That's just example. More industry from JDA contracted industry has joined this meeting. So last but not least, they are waiting for B2B meetings here. Thank you very much.
This is Kijung, head of Korean Domestic Agency. I'm also very happy that I present to you the status of KODA program activities. I'm wondering whether I can see well the screen, because my eyes become very old because thanks to Iter project. So as you see here, Korea is responsible for 9 procurement packages. For example, toroidal field conductor. Of course, that was delivered a long time ago. I can say 2014, so more than 10 years ago. And I see here vacuum vessel, 4 sectors also is responsible from Korea. And blanket shield block, I see here, and some others. I need to check my paper, otherwise I cannot see that very clearly. And we have also assembly tooling. This is more or less 100% responsible from Korea. And AC/DC converters around 40% remaining from China. And diagnostics, almost 2% is responsible from KODA. And tritium SDS. So in total, we have 9 procurement packages. And you see here the status of the actual manufacturing and the delivery, the status. First of all, TF conductor, as I said previously, we have delivered already all the TF conductor since 2014, more than 10 years ago. And we are very happy, and this morning, Director General Pietro Barabaschi mentioned also about the vacuum vessel. We were responsible for 4 sectors of vacuum vessel, 2 from originally KODA, the procurement packages, and 2 others from European FOE, and we successfully delivered. And the last ceremony on completion of the delivery was held last year, in November last year. I was witnessed there and very happy to successfully done all the work. And thermal shield as well. As mentioned this morning, Director General Pietro Barabaschi, there was some technical troubles, but globally speaking, the manufacturing was very successful, and we finalized all the delivery of the TF thermal shield as well. And assembly tooling. One of the biggest example of the assembly tool would be SSAT. You can see, or when you come to assembly hall, this is Korean small and medium company manufactured and delivered. So and at the same time, you can see also a pending tool which was delivered also from Korean Domestic Agency. So these 4, we finished all the deliveries, and globally speaking, many critical items we have had. The reason why, globally speaking, and budget point of view, almost 91% achieved from KODA. Many talks about supply chain. Of course, the Korean KODA, together with the Korean government, is always emphasizing the importance of the maintaining a sustainable supply chain for the fusion development. More than 200, medium, small company, except HD, Hyundai Heavy Industries are involved. So all the others are small or medium-sized companies. I will tell some of them as an example. KAT for TF strand manufacturing, and as I said, HD HHI for manufacturing vacuum vessel, a main and port, and thermal shield, Samhong machinery, and assembly tools using MS, and AC/DC converters from Taiwan CS. Even now, the blanket shield block from EMK. And I cannot mention all the other supply chains, but they are contributing a lot for the success of the Iter project. And I will tell you about ongoing procurement activities. We have 4 remaining procurement packages. I can say, first of all, vacuum vessel port. This is the equatorial and lower port are responsible from KODA, and under the manufacturing, the HD, Hyundai Heavy Industries. But we are sure that we'll deliver all the procurement packages by end of 2026. So meeting all the schedule necessary. And for your reference, I mentioned here vacuum vessel craft support that will be delivered also, that have been delivered by end of last year. So everything done. I'm very happy that very soon this will be installed at the pit. About blanket shield block, we are responsible for 220 shield block, half of the shield blocks, and among them 130 already completed the manufacturing. And this year we are planning to deliver to each organization about 90 shield blocks. Of course, we are meeting all the schedule, probably ahead of schedule. And coming back to the AC/DC converters, of course, Korean domestic agency together with Chinese domestic agency, we have all delivered all the AC/DC converters and installed also. Actually, legal inspection and commissioning of the components are started. So this will be probably finished by, all the commissioning will be finished by 2028. So Korea also was responsible and manufactured and delivered master control system on site. About diagnostics, Korea is responsible for 3 VUV spectrometers, neutron activity system, and upper port number 18 diagnostic integration. I can say that the full final design of all system and some components of manufacturing is ongoing. This is, I can say, also as planned. So this will be, and as Taro Matsumoto-san mentioned, we have really good collaboration with Japanese domestic agency about low port 02 manufacturing. So we are working very closely and very effectively. So I will just mention 2 the items that is upcoming procurement. So first of all, SDS, tritium SDS. This tritium storage and delivery system, the procurement arrangement signature was done just last March together with Pietro Barbarsky. And I'm very happy that this is the last PA signature done between Director General of Iter Organization and myself. So now we are meeting to all the schedule and the quality, everything and on time, so that the fuel cycle be assured by Korean domestic agency as well. Of course, there are many technical challenges, complicated, operational mode, or the SIC signals, or tritium compatible component. Some difficulties that we have, whether we can, secure all such kind of typical compatible components. In any case, we'll do our best to meet all the schedule and on quality. Lastly, TBM, test blanket module. This test blanket module will be procured together with European FOE. The collaboration arrangement was signed several years ago, and all the work are really ongoing. I'd like to express my sincere thanks to European domestic agency also. So of course we'll have many challenges, but we are ready to overcome, working together with closely FOE and Iter organization. This is my last slide, and I can say that we have also some stand from Korean industries, and our stand is number 7, so I'm very happy. I'll be very happy when you visit our stand. Thank you very much.
Good morning. Thank you very much for you to come, and thank you also to organize this meeting again. Very useful, very productive, I am sure it will be. And we have a lot of interaction with especially European companies in the field of our responsibility, also with Japanese company, also with Chinese company, and our interaction with China increase, and I very much hope it will be very helpful for Iter project. What I should mention also that due to Pietra Brabaski leadership, our project becoming more technical project, and smaller international organization, and this is also very important. And also I should mention that all Iter organization leadership, all team today are very, very professional, and we are really successful due to this arrangement, and this gives essential possibility for industries, for companies to interact with professional people and to accelerate our project as it's possible, and this is crucially important now for public. Now about our Russian activity. First of all, I should mention that Rosatom responsible for Iter project in Russian Federation, and Russian domestic agency, which is an institution of state corporation Rosatom, responsible for all collaboration, manufacture, development, manufacture, delivery, installation, all equipment here on site. And from this point of view, we interact with industry. We are totally open for all international contact, no any restriction from Russian side. That's why I am totally open to invite you for any interaction. Russian representatives here also in this hall. And we very much hope that during these 2 days a lot of useful interaction will happen, and this will happen for our Iter activity, and also domestic agency, ITER domestic agency, very much involved in internal program, and we are now finishing design of our internal machine, tokamak with reactor technology, and we very much hope that our ITER partners, industry from ITER partners, will be involved in this project, and we are trying to do it as interesting as possible for your participation. Nothing? Okay. Open. Content of presentation. This is our responsibility. Some system already finished, some system in progress. We are close to develop and manufacture our diagnostic system, and I will present you some most important events. First of all, colloidal field coil number 1, finished, manufactured, and supplied here to the ITER organization. This was not very easy, but it's done. Next, this figure shows how we arrange transportation from St. Petersburg to Marseille. This colloidal field coil number 1. We finished our manufacture and testing of all our gyrotrons. All gyrotrons corresponds to ITER requirements, 1,000 second, 1 megawatt, and efficiency more than 53%. This is higher than ITER requirements, and we, according to ITER request, we plan to continue this activity due to decision to increase electron cyclotron heating power. We successfully provide connectors for vacuum chamber. Here, DeLeah Institute responsible and arrange this manufacture, and DeLeah representatives here in this hall. We finished manufacture prototype of central part of diverter from tungsten. This prototype now here in ITER, and we are now starting the construction for ITER machine. Switching network, Yefremov Institute responsible for all switching network in frame of our responsibility, bus bar network, and this work in very good progress, and we sent around 30 lorry from Petersburg to ITER each year, and this is very important to keep the schedule of ITER construction. Test of diverter component, special bench created and efficiently used and using now for testing of ITER diverter component again in Yefremov Institute in St. Petersburg. About diagnostics, formally we responsible for 7 diagnostic complexes, but really we trying to increase diagnostic power and to add additional diagnostic to our responsibility, and total our responsibility now is 13 diagnostics. Here you can see a lot of diagnostic, 3 optical diagnostic, 2 neutron diagnostic, neutral particle analyzers, neutron spectrometers, gamma spectrometers, reflectometry from high field site, and in all this system we have very good collaboration, international collaboration with our international partners. Port plug test facility for installations we manufacture in Russia to test all port plug before installation to machine, and this activity in a very good shape now. This year we plan to supply first main parts of first installation to start installation of this machine here in Iter site to provide possibility to keep schedule for diagnostic port plug testing here. Conclusion. Conclusion is that we are trying to be in schedule in our activity, and the second point, due to new baseline, we initiated, and the ITER organization support our initiative to study possibility to use boron 4C coverage on tungsten first wall components. This work now in very good progress. We hope that in nearest future we will provide data which will help ITER organization to make decision about possible usage of boron 4C in ITER machine in future. And one more time, I want to say that we are totally open for all our collaboration in future, and I want to say big thanks to those companies who collaborate with us now and who help to keep good relations in this not very simple time. Thank you very much.
Good morning. It's good to sort of see everybody out there. Mostly you're pretty dark, though, with the lights. It's my pleasure today to talk to you about some highlights with US Iter. I'm Kathy McCarthy, and I am the US Iter Project Director. In terms of the US scope, some of the hardware is complete, and most of it is in fabrication. And I'm not going to go through these things in detail, except to point out a couple things. The US was responsible for contributing 8% of the toroidal field conductor. That has been completed. We were also responsible for providing 75% of the steady-state electrical network. That is also complete. And there are systems now that are close to completion. And so overall, we are just over 50% complete in terms of delivering the hardware that we're responsible for. There's industry, universities, and national laboratories from across the United States that are contributing to ITER. We have distributed or awarded over $1.4 billion since the project inception. Now, this just shows you places in the United States where work is being done to support US Iter. We also have contracts with companies outside of the United States, and I'll talk a little bit about that on a later slide. We're continuing with the design, fabrication, and deliveries, and since 2017, we have completed over 200 deliveries. And as I mentioned, this is just over half of the US responsibilities. And you can see some pictures here of some various components. that are either in fabrication or have already been completed. In terms of recent accomplishments, you heard a little bit in Pietro's talk about the central solenoid magnets. The United States is responsible for the central solenoid stack, which is made up of 6 modules. We are also responsible to deliver a spare. This particular scope was considered the most challenging in the US portfolio, and I'm very pleased to say that we're close to being finished. As Pietro mentioned, the 4 modules are now stacked in the assembly hall. A 5th module is on a truck approaching the Houston, Texas harbor, and then it will be shipped to France. A 6th module has passed all of its testing and will be prepared for shipping and will ship in the next couple of months. The 7th, the spare module, as I said, we're responsible for a spare, has also been manufactured. All of our modules undergo extensive testing. They have all been brought down to 4 degrees Kelvin. We put power on them, and there's extensive testing both prior to that thermal excursion and post cool down. And one of the things Pietro mentioned was we had an issue with one of the modules, a fault. It was actually a fault with the test facility. You have to know that testing can also cause issues. And the arcing that occurred dumped energy into the module and did some damage. That damage has been repaired, and we'll do the final testing on that in the next few months. We are also responsible for central solenoid support structures. We delivered the last of those to the Iter organization earlier this year. In terms of upcoming procurements and opportunities, I want to talk a little bit about our tendering and acquisition process. So the work that we do, the contracting that we do is of course in accordance with US laws and policy. And the Oak Ridge National Laboratory operates under the US Department of Energy prime contract. That also dictates how we do things. And then, of course, we have procurement arrangements with the Iter organization that dictate what we're responsible for. All of our acquisitions are conducted as competitive best value procurements with evaluations that are based on both technical and price factors. And so that's an important thing to understand, is that it's best value. And foreign suppliers are encouraged to participate in US Iter procurements. And we should note that there's something called the Buy American Act in the United States. It actually does not apply to the equipment that is being delivered to the Iter site. So again, I encourage all companies to watch our website. We do advertise our procurements there, and of course through our official procurement system. In terms of upcoming procurements through calendar year 2026, they span multiple hardware systems. At the high level, for example, electron cyclotron transmission lines, ECH heating is needed for heating the plasma. And there's multiple pieces under each of the major categories, things that will be done in separate procurements. Vacuum auxiliary and roughing pump systems, this is for the cryostat vacuum. There are multiple procurements that will go out in 2026 under this topic. Tokamak exhaust processing system, this is for tritium recycling. Again, multiple procurements will be let in 2026. And then finally, a pellet injection system. This is used for plasma fueling. And you'll see a couple of procurements going out this year for that hardware system. Our future procurements will focus primarily on diagnostic systems. Our diagnostic systems are still primarily under design, with some procurements that have already started. In Iter, one of the real values of Iter is the fact that it will be highly diagnosed with well over 50 diagnostics. The US is responsible for 7 of those diagnostics. It is the information that will come from those diagnostics that's needed both to run the machine, but also to inform how we actually optimize and get to commercial energy. The diagnostics use microwaves, photons, diagnostics. They'll measure plasma profiles and many different pieces of the plasma profiles, all that are very important for understanding how to get to practical fusion energy. So with that, I will wrap up. The one thing I want to close with is I started my career in the early design phase of Iter, and it's really exciting to see it coming together. And if you haven't toured the site, I would encourage you to do so. It's so much progress and just really great to see everything coming together. So with that, thank you.
So thank you to the panelists for sharing a little bit about the opportunities and progress, challenges that you've gone through on this journey. I'd like to start with a few questions. We have about, I think, 10 minutes left in the program for this. And Kathy, I will start with you. With respect to developing a supply chain for Iter, given the unique requirements for cutting-edge technology and materials, how have you managed to build and maintain a robust global supply chain that meets Iter's needs?
So one of the lessons learned in this area is when we put out procurements, the more specific it is, the more we know about it, the more bids that we get in. And so we will, for example, do prototyping often in order to inform our procurements, and that helps a lot. We also work very closely with our vendors, and our technical monitors spend time with the vendors. In some cases, one of the areas that many of our vendors had problems with was the environmental qualification portion of the contracts. And so in those cases, we had to work very closely with them to help them to develop an environmental qualification program that worked for Iter. So those are a couple of examples, but and we've seen a lot of progress and a lot of improvement.
Thank you. Anatoly, I'd like to ask you about some of the unique challenges that you've faced. How have you balanced the need for immediate results with a long-term vision that's required for a project of this size?
Okay, thank you for this question. It is really not easy, and it is, I think, one of the main questions for our project, for Iter project. Most important question to keep public belief in our fusion project. Very essential challenge. And I think people still understand two things. First of all, very essential challenge for what we are doing here together. Because let's imagine we have 300 million degrees at the plasma axis, and we must have 5 Kelvin degree on our toroidal coils, and distance only 3 meters. And duration of Iter pulses 1,000 seconds. And engineer should provide decision to stop neutron and gamma ray flux to arrange this operation. And so engineering question very essential. But about how we keep public, I think clever people understand that only one possibility for us is fusion in future. So from the many point of view, I don't want to repeat. First of all, safety, non-restricted fuel, very compact fuel, very light fuel for interplanet trips and so on. Nothing possible without fusion. Everybody understands this, and people already ready to wait. But we should provide good signs for the public, because when we had competition between United States and Soviet Union last century, we compete who construct next machine first, PLT or T10, and so on. No competition. Iter killed competition in the fusion world. We create collaboration, but we killed competition. What is better? We should demonstrate that collaboration better than competition, but competition also very powerful. So we should have both collaboration and competition, and we should understand that we don't have unlimited time for ITER project. We should accelerate ITER project as we can. So schedule is the most important driver of our success. This is my opinion. And we are trying to do this.
Thank you. Kijung, I'd like to ask you a question about partnerships, because Anatoly just touched on collaboration. Can you give an example of a collaboration between ITER and the external organizations that you've encountered?
Thank you very much for your question. I think I can take on a very nice example that was taken just a few time ago. In Korea, there's one the startups established last year. The name is Enable Fusion, and they are collaborating with other the supply chains for example, the competing with other companies, etc., the worldwide market. And then recently, they could get a contract very soon, probably, a contract award. But the manpower itself is not sufficient enough. The reason why Enable Fusion asked us some collaboration agreement between KODA and Enable Fusion, ENF. And we made conclude this one very recently. And the KODA is ready to support technically, of course, all the the vacuum vessel. We have largely enough experience for that. So it will not be the end, but in the future also, we are ready to collaborate such kind of work. This is public and private, collaboration. I think it's a really good example and could be applied for other domestic agencies as well. And the domestic agency, collaboration, as mentioned, Taro Matsumoto, the LP02 collaboration, manufacturing between JAD and KODA is a really good example. And the TBM on, the collaboration, probably Marc can say something more, but, it's really good, the collaboration and working together is something synergy between two partners. Thank you.
Taro, I have a question for you relating to strategy. So what strategies have you used or have been most successful in fostering trust and coordination among your partners?
All partners. Thank you, DeLeah. Yes, so it's as Kijung-san said, it's very important to have a collaboration. But in order to make real collaboration, it's very important to make close communication. We have different culture, different language, but we should make one team to make a good collaboration. So it's very important. Yes, from my experience in the ITER project, yes, now we finally had one ITER team. And we have a good collaboration or, yes, a good relationship between the private sectors. For example, we provide our facility to Kyoto Fusion for their test of something. So now we are establishing the network between the private sectors and public sectors. So to reduce the cost and to reduce the schedule duration for the mission. So in order to achieve that mission, we would like to have close communication. Thank you very much.
Thank you. Narinder, I want to ask you about mega projects. So Iter is one of the largest and most complex scientific and engineering endeavors ever undertaken. What key lessons learned can be shared about managing expectations for such a project in terms of scope, cost, budget, schedule? Anything you can share as a lesson learned?
Yes, I think thanks for the question. I think the mega project, as DG has said, should be driven by passion. That is very important. And we should have collaboration with the people who are passionate about that project. And because it takes a long time to deliver the things. So maintaining good relations with your suppliers among your team, and it is also very important that you keep on bringing the young team, young people into your kitty. That is really helpful to manage things. Otherwise, the situations you deal at the site, you can always find a technical solutions to those problems. But having a continuity between the responsibilities, scopes, and the different age groups, it is very important that we pass on the baton very carefully among a motivated team. So I think the very important part is to keep the motivation on. Thank you.
Thank you. Marc, I'd like to ask you a question about attracting top talent. Given the highly specialized nature of Iter's work, how does an organization attract, retain, and develop the world-class talent that's needed at such a project as Iter?
Thank you. Thank you for your question, and it's clearly in line with one of the pillars I was mentioning before. I think if somebody has an idea or the best idea, we can share, because I don't think there is a unique recipe. I think it's a mix of factors. The first factor is to be aware of what we do and not to be shy of what we do. I think here we're all conscious, but sometimes we forget. We're building something which is really unique. And I'm sure when you talk to people outside of this fusion community, at least when I do, they're fascinating. This is fascinating. I mean, what we try and what we will achieve is so unique that just the simple fact to explain what we do is interesting people. So the first thing is explain what we do and be humble of what we do as well. And it's to say it's a journey, and it's to convince the people that it's a journey for years. And we have a lot of examples in our industry, in the project, in FOE, people building fantastic careers with fusion. They were in JET 20 years ago, and then they moved to Iter and come to Fusion for Energy. And we have many stories like this. And I think telling those stories to the young generation might be different. They might start in GT60 for a few years, and then they will finish here the assembly and see the first operation, come back to the national lab, whatever. But I think the visibility in terms of career, and I think we're dealing also with such a big asset. I mean, we're not making day-to-day objects or fast fashion. I mean, we're here for years, and I think to attract talent. So communication, not to be shy about what we do, and then make sure we manage properly people. And this is maybe our challenge, because I think we're still coming from a culture which is based on science, and I think people need to be managed in the sense that they need to be listened, the wishes need to be taken into account, and we need as managers to let them grow. And this is probably the biggest challenge. But definitely it's something we need. I think we have very good examples of young people coming. I pay attention to meet personally all the newcomers of FOE. I can tell you they have something in their eyes which is really refreshing early morning when I see them. So thank you for the question.
Thank you. Min, I'd like to ask you a question about new companies. What advice would you offer to a new company interested in working with Iter or contributing to Iter or a similar large project like this?
To be honest, it's not an easy question. Yes, from my point of view, firstly, the new company should fully understand the nature of the project. And secondly, they need to provide a stable group to follow the project, because it's just like the so huge project that will spend much time, a lot of interfaces, a lot of communications. So we need some stable group, not big one, maybe 1 or 2 person, but we need stable. Thirdly, the close communication is very, very necessary, because there are a lot of knowledge and requirement will be provided during the conference or maybe meeting discussion like that. So that close communication is also needed. And the last one is we please update the knowledge as soon as possible. Thank you.
Thank you, Min. I'd like to thank each of my colleagues for taking time to share their progress, their opportunities, and lessons learned today. When you think about a road trip, usually about 20 minutes into the trip, somebody says, "Are we there yet?" Well, we're not quite there yet, but it looks like we're putting things in place to be successful and make it a very impactful journey. Thank you all for your attention.